Hi, everybody. Welcome to Math 60. We are talking about section 2.4 today, which is solving equations and getting unexpected results, what your textbook calls special solutions. So let's just give you an example of an expected result first. So if I have something like the equation 3x plus 2 equals 10, not 10, 14. 3x plus 2 equals 14. And I want to solve for x. The first thing I'm going to do is going to get all the x's by themselves. So I subtract 2 from each side, and I have 3x equals 12. And then I'll divide both sides by 3 to cancel that 3 out, and I get x equals 12 over 3, which is 4. Okay, cool. And then I check. 3 times 4 plus 2 is 12 plus 2, which is 14. Okay, got it. So that's an expected result. We have an equation, we solve it, we get an x value. But sometimes when we try solving equations, we get unexpected results. For example, let's look at 3x plus 2 equals let's change it up. Let's say it's 4x plus 2 equals 2 times 2x plus 8. Now we worked a little bit on order of operations. If I want to get all the x's on one side, first I have to get all of this right side multiplied out. So 2 times 2x becomes 4x, and 2 times a positive 8 becomes plus 16. And my equation is equivalent to 4x plus 2 equals 4x plus 16. So I want to get all the x's on one side, so I subtract 4x from one side, and I get a surprising result because 4x minus 4x is 0 x's. These cancel, and I'm left with 2 on the left side by itself, and the 4x minus 4x cancels, and I get 16 on the right side by itself, and that's not possible. 2 definitely does not equal 16. So I got an equation and I was asked to solve for x, which is a mathematical way of saying find all the x values that make the equation true. Well, that equation 2 equals 16, that's never true. And in particular, it does not matter what value of x I choose, that will never make 2 equal 16. No value of x will ever make 2 equal 16. So there are no solutions to the original equation. That is one of our surprising results. When you have an equation and you do the math correctly and you end up with what's called a false statement, like 2 equals 16. Another possible surprising result might look something like this. Let's look at 3x plus 4 equals 1/2 times the quantity 6x plus 8. And we'll solve this. Three x plus 4 equals 1/2 times 6x plus 8, and I want to get the x's on the other side. So the first thing I'm going to have to do is I'm going to have to multiply that 1/2 through. So I get 1/2 times 6x plus 1/2 times 8. And 1/2 times 6x is 3x. And 1/2 times 8 is 4. And maybe you can see where this is going. I've got an equation that looks the same on both sides. So when I subtract my 3x to get them all on the same side, and they cancel, I end up with the mathematical statement that 4 equals 4. Okay, well, this is always true for any x. Doesn't matter what x I pick, 4 will always equal 4. So there are actually infinite solutions to the original equation. Oops, sorry. Infinite solutions to the original equation. So most of the time when we solve equations, we get 1, maybe 2, sometimes even 3, but a fixed small number of solutions. In this one, x equals 4 is the only value that makes the original equation true. Every once in a while, we might find an equation where it's never going to be true, where no value of x makes it true, and so that equation has no solutions. And sometimes we get an equation where any value of x would make it true, so that there are infinite solutions. Those are surprising equations or equations with surprising solutions. We can also have inequalities with surprising solutions. So just using, let's start with an unsurprising. Let's look at x minus 3 is less than or equal to 2. And if we solve the equality first, we could answer it. But this one to me is simple enough that we can just do that one arithmetic operation and get that x has to be less than or equal to 5. Okay, this is a set of solutions, but it's not surprising. Here's an example of a surprising inequality. X minus 3 plus 2x is less than 5x plus 4 minus 2x. So if we want to get all the x's on one side, maybe it makes sense to start by collecting them, collecting those like terms. The x and the 2x add together to be 3x. So I have 3x minus 3. And on the right side, the 5x and the minus 2x also combine, and I have 3x plus 4. And then I'll subtract 3x from both sides. And those cancel out, giving me an unexpected result of simply comparing two numbers. There's no x in this solution at all. Well, -3 is always less than 4. This is always true for any x. So I have all values of x from -infinity all the way up to +infinity are solutions. And that's surprising. We don't expect that when we solve an inequality. We expect to have some kind of endpoint on our solution set. We don't expect it to be every single x value that we could ever think about. And another surprising solution you may be able to guess is when you end up without any x's that make it true, also in an inequality. So let's look at something like x minus 3 plus 4x is greater than 5x plus 6. I have to work a little hard to disguise what's going on here, because if I just started with those x's combined, you would see that most of the time our surprising solutions involve a step where you have the same number of x's on either side of your symbol, whether it's an inequality or an equality. Let's subtract 5x from both sides. Those cancel. And we're left with minus 3 is greater than 6. No, that's not true. That's a false statement. So my original inequality has no solutions. The difference between equations and inequalities, the process is the same, the possibilities are the same. You could have, or similar, you could have a solution set that has a fixed endpoint. You could have all real numbers being a solution set to an inequality, or you could say, nope, that's never true. The inequality has no solutions. But the process for finding surprising solutions is just the same as the process for solving. You solve the equality or the inequality. If there is one solution, cool, right? X equals 4, or one endpoint, x less than or equal to 5. That makes sense. There are times when you have more than one solutions. You could have x equals 2 or also x equals -1. But in our world, that's not surprising. It's still a finite, discrete set of solutions. And here you might have what's called a compound inequality, which is like 2 is less than x is less than 8. You might have infinite solutions, which in the world of an equality is when you say something obvious like 3 equals 3. And in the world of an inequality, it would also be something obvious like 2 is less than 10. Or it can have no solutions, where in the world of equalities, you have an equality that's obviously not true. 3 is not equal to 4. And for inequalities, it would be something that's obviously not true, like if you end up saying that 5 is greater than 12. That's obviously false. 5 is not greater than 12, and so there are no solutions. So these are the surprising results you can get when you try to solve equations or solve equalities, but your process is still the same. You just try to solve it, and either you have one, or maybe more than one, or maybe infinite, or maybe 0 solutions. Inequalities, you can have one interval. Maybe you could have 2 intervals. Or you could have just all numbers. This means that any number at all would work, because 2 is always less than 10. Or you could have no solutions if it's something that's obviously false. If you try to say 5 is greater than 12, that's obviously false, and so there are no solutions. All right, that wraps up our video, and tune back in for the next one. Thanks.